Okay, right, ladies and gentlemen, good morning. Good morning, Mr. Lesham is here. We've got quite a packed up lesson. We are going to do trig graphs, okay? So luckily we had a few extra minutes at the end of last lesson, so I managed to just remind you what we know from grade 11. So I'll very quickly, just like 1 minute quickly, talk about trig graphs, and I'll pick a sine graph, but it's the same with cosine and tan with a small difference that I will mention. So we've got your mother graph, which will be y equals sine x. And you remember, you should by now hopefully know the shape of the sine graph. Okay? Now we throw a bunch of parameters on it. Okay? So I know we spoke about it, so I'll just very quickly remind you that the A is your amplitude, okay? The height of the graph, okay? The distance, or the maximum minus the minimum divided by 2, really. That's more accurate way of calculating the amplitude. The Q is your vertical shift, up or down. You can take your sine or cosine tan, move it up and down, okay? Your P is your horizontal shape. Okay, so when we have, let's say, for example, in this case, x plus 45, that means we shifted it to the 45 to the left. Well done. Okay, so we took a cosine graph and moved that 45 degrees to the left. Well done. And then K is the trickiest one. K stands is to do with the period. Okay, so it's exactly, you're right. It kind of compresses that little thingy, that little wave function, okay? And I think best thing, if you just remember, okay, just remember that K is equal to, or the period is 360 divided by K. This is for sine plus cosine. So I'm not going to do plus because then you're going to start thinking we're adding something, okay? So for sine, cosine, the period, okay, that basically the length that gives you one cycle of 360 over k. Okay, when k is 1, then the period is 360. That means after 360 degrees, we start where we went back to where we started from. Okay, all right. For tan, we know it's a little bit different. Okay, the period, yeah, that's it. It's 180 over k. All right. Okay, so let's use this to solve this problem. So we've got. I'll just pause for a question. You on? Yes, you are. Okay, so I've got two graphs. I've got f of x cosine x plus 45. Okay, you can see that I've just plotted half of the cosine. Okay, a normal cosine graph is normally, what is it, like this. Yeah. Okay, so I've moved it. You know, this is really just half of it. I've moved the 45 to the left. Okay, then I've got sine 2x. Which has been compressed a little bit. Okay? They start with some simple stuff. What's the amplitude of f? 1. Yeah. You can see that the coefficient in front of the cosine is just 1, so the amplitude is 1. Okay? The period of g. Well, the k is equal to 2. So the period will be 360 divided by 2, which is 180. Okay? A normal, or period of a normal sine is 360, but when I have that 2, okay, the period is going to be 180. That means every 180 degrees, you go back to where you started. Okay, now we need to find out some coordinates. Okay? I'll just pause to write all the rest as well. Right, so now they're asking us, what's the coordinate of A? Remember, coordinate, we always have to have the x and the y. Now, I claim that the y we know straight away. What will be the y? 1. It will be 1, because we already said that the amplitude is 1. Okay, the maximum can get is to 1. Okay, so obviously A is the peak there, so it's going to be 1. The question is, what will be the x? Very good. And how do you know that?
Because on the cosine graph, it starts on 1.
That's it. Okay, so a normal, well done, Jimmy, okay? So y equal cosine x, okay? The cos graph started at 0, 1, okay? but now we have x plus 45, so we shifted to the left. So that has moved 45, so the maximum is going to be at minus 45. I'll just pause to make sure you guys are happy with that. Alright, so to find out b, I already did with you, and I realized what's the easiest way of doing it. Okay, you can straight away see that b is directly below a. Okay, so really it's the same x value. It has to be the same x value because they're above each other. Okay, but if I put minus 45 in here, I'm gonna get sine minus 90, which is, if you can put it in your calculator, it's going to give you minus 1. But you can also see it that this is the amplitude here, and I know the amplitude of this one is of g is 1. So in other words, it swings between minus 1 and 1. We happy with that? On fire today. Well done, Genie. Okay. So C. Okay. We want to find the coordinate C. So first of all, I know that the y value is what? What is the y value? 0. So I'm asking myself, when is this going to be 0? When is sine 2x going to be 0? Okay? Sine is 0 at 90 and at minus 90, right? Or am I wrong? No, sorry, at 180.
Yeah, it's 0. Normally 180.
Sine is at 0 at minus 180, right? Okay, sine, okay, here we go. Sine is 0 at 0 and at 180, and if I go to the other direction, also at minus 180. Okay, so if I've got 0, it's here. But if I want to have minus 180, I need the x to be minus 90. So the answer is minus 90. Well done, Genie. Now that was really a warm-up. Okay, I know it wasn't that easy, but it's still warm. Now we're looking for more difficult things. So they're asking us for Q. Q, what do we call that point? Intersection. And what do I need to make them equal, isn't it? So I'm basically solving this equation. That's the equation I'm solving. Okay? Now I'm not going to solve it completely. I'm going to get started, but we've done a whole lesson or two really about solving trig equation. But let's just see how do we do it. What happens when I have cos and I've got sine? But I've got two different arguments there. I don't have x plus 45, x plus 45. If I had that, then I could just do tan x plus 45 equal 1. So I want to make sure it's let's say cos on the same side. So if I want to have this, how can I transform this into a cos?
You can say 2 sine x cos. Right?
Well, I don't, yeah, that's automatic thing. You look sine 2x, you think 2 sine x cos x. Good that you're thinking, but it's not going to help you here. Because you're still stuck with sine x, cos x, and then cos x 45. So what did you say, Tyler? You said something else. That's it. So whenever I have the sine, which I want to convert to a cosine, you just do that. Remember that one? Okay. Now, that sort of stuff, that means there's two options. Okay. Either x plus 45 equal to 90 minus 2x. And I need to add 360k and all that sort of stuff. Or x plus 45 is going to be, when is cos positive? 360 minus 90 minus 2x, if you know what I mean. Well, that's 360. Okay? Why is that? Because cos is positive here and here. Right? Remember, I've got two solutions. Now I'm just going to pause and write down the solutions, and we'll choose which one is the one we want. Right. So I've saved up some time. Ooh, this is a little bit loose. Okay, just going to tighten. That's it, guys. So as I said, I can't remember what I wrote first. So we have these two options to solve. That's a general solution. That means k can be any integer. Okay, and then I went ahead and find what x. And I subbed k equals 0, k equal 1 in the first solution, and I got 15 degrees minus 105 degrees. Obviously I can carry on, but I just stopped there. And then x, from this solution I get minus 225 and 135. That's not plus, these are two different solutions. There's obviously more, but the rest will definitely be beyond. Now the question is, when I look at q, which one is the right x out of these four? There's only one possibility out of these four that Q is. Which one?
Oh wait, no.
It is 15. Look, that's why you gotta look. Look, this is 45. It's between 0 and 45. That's the only one. So for Q, we're gonna have 15 degrees. Okay. Now, how will I find the Y value?
You sub 50.
You just sub where?
Into anyone.
Anyone. Easiest to me to sub here.
So
Sine 2 times 15 is sine 30. What is sine 30, guys?
Special angle.
Sine 30, guys. Yes, it's a half. Okay. So that's the coordinate of Q. Okay, I'm just checking. Yeah, we got it right. Now, I didn't ask you, but I will ask you now, because they do ask us, what's the coordinate of P? Simon, are you with us? Okay. What is the coordinate of P?
P.
This is P.
Oh, so that'll be.
Which out of these can it be? Negative 105. So it's going to be negative 105. And the Y coordinates, you can check it, it will be probably the same, isn't it? It looks like it's the same, it is. But you just sum it. Okay? So you've got P, you've got Q, and you've got P. We happy with that? Okay, chaps, we're moving on. This was actually the hardest bit. Now it will become a little bit easier. So I've put all the coordinates, okay? That means this is minus 105. This is minus 135. This is 45. This is minus 45. This, if I'm not mistaken, is minus 90. I raised it. Okay, we found it once upon a time. Okay, this is obviously 0. Now, this kind of question is for which values of x, and then there will be a bunch of stuff we need to calculate. The first one is, when is f smaller than g? Let me ask you what that. F smaller than g, that means when f is below g or f above g? Below. F smaller than g, basically they're asking us when is the red graph below the black graph. So it's here and there. It's very important to be able to do it with your fingers. It's this area and this area. Yes, Gene?
So these graphs don't continue, so you just go to like where they
Yeah. We stop here. We just stop there. Yeah, absolutely right. So they're not interested in what happens after. They do continue, but we're not interested in it. This is fine. Yeah. Okay. So it's going to be x smaller than or larger than minus 3.5 or equal. Smaller or equal to minus 105. Can you see why?
Is it equal or no?
Well, what are they asking us? It's not, because they're asking us, it's not equal because it has to be actually smaller. So it's equal sign on this side. I'm just checking that I've got it right. Yeah, it can be equal on this side, but not on this side. Okay, but there's another option right here. Okay, the grid graph is also this. So I have all x bigger than 15, but not equal, smaller or equal to 45.
Why is that not equal?
Okay, let me just pause and I'll explain. So I wrote it now, and from your reaction, I can see this is your all-time favorite. We are asked to find for which value of x the product of these function smaller or equal to 0. Really, what it means is that for a product of two number, multiplication of two number to be smaller than 0, that means what? That one of them has to be negative. One positive, one negative. If both of them are positive or both of them negative, the product will be positive. So one of them has to be negative, one of them has to be positive, right? Now what you can do, let's do it like this. I hope you can see it.
One of them can also.
Yeah, one of them can be 0. You're right. Because I have equal to 0, it also means that one of them could be 0. You're right. So straight away we can say this is 0, and this here is 0, and this 0, and this 0, and this 0. We include them. But what I'm going to do, I'm going to basically write down. Look, I've got four. I don't know. I've got many sections. Okay. I've got this section up to here. Well, actually, you know, I don't even need to do that. What do I know about x in this whole region? It's positive. Can you see it's positive everywhere? Okay, apart from the edges. So the edges we can include, okay, because it's going to be 0. But the rest of it is positive. So already the question is, when the black one is negative. When the black one is negative, the product of f times g will be negative, right?
So from
Yes. So it's going to be x larger or equal to minus 90, smaller or equal to 0, right? and including the edges because that's fine when it is 0. But we also need to add these here because we said these guys, the f is 0.
Yeah.
So it's going to be or x equal minus 35, minus 135, or x equal 45. Okay, let's see if we got it right. Okay guys, this is a good question to be able to guess. So they're asking, when is f minus g equal to 2? When is f minus g equal to 2? Yeah, okay? Because look, if this is 1 and this is minus 1, when is the difference between them exactly 2? Okay? At x equal minus 45. Happy with that? Well done, John. Chaps, minimum max problems. Normally if I say minimum maximum, what comes into your mind? Which chapter is it? It's calculus. And calculus is the way to do minimum maximum. And it can be done. We can do this with calculus, but you can't because you don't know how to do derivative of sine and cosine. Okay? If you want to do that, that's no problem, but you've got to do AP maths. Okay? So you can ask us as Josh. Okay? But luckily for us, they're going to ask this question where you actually don't need calculus. So they give you this sine x cosine x, and they're asking you what is the maximum that this can be, maximum and minimum. So when I tell you sine x cosine x, what comes in mind? You thought about
2 sine.
Yes, it's 2 sine x cosine x, but then I need to divide by 2. So it's going to be sine 2x divided by 2. Now, what is the, so it's basically going to be half times sine 2x. What's the maximum that sine 2x can be? Let's leave the half. What's the maximum?
2.
No. What's the maximum that sine 2x can be? Okay, now let me ask you another question. If I've got y equals sine x, what's the maximum that y can be? Maximum of y. Y maximum will be what? What's the maximum that sine x can be? 1. Okay, that's the meaning of the amplitude. The maximum it can be is 1. Right?
So it is 2. It's 2. Yeah. It's half.
This,
it's half.
well done. Okay. So the maximum is going to be half times the maximum of sine 2x. Okay? Half times the maximum of sine 2x. But the maximum of sine 2x is the same as the maximum of sine x. Okay? What is sine 2x? Sine 2x is the same as the sine. It's just squished. Okay? So the answer is going to be half, like what you said. You're right.
Do not
I'll just pause. I'm sure there's some questions. Guys, just about the last question. The maximum was a half, but we didn't answer what was the minimum. If the maximum is half, the minimum is? Negative half. Okay? Okay? Right. Now I'm going to do this one because I didn't do something similar in the last question. So again, what is the minimum, maximum of this function? Now when you got that, remember that when we have a sine, or like a cosine is on, or a sine on is on, then a cosine, the other one with a number, you're going to think about special angles. So what we're going to do is, we want to turn that into square root 3 over 2 sine x plus half cosine x, but that means we need to multiply the whole thing by 2. Just have a look at this. It is a tough one. Just see that, not why we're doing it, but you can see that you're happy with it. Because if I multiply the 2 by half, I'll get square root 3. If I multiply 2 by half, I'll get that. Are you happy with that?
Yes.
Okay. Now we're going to leave this 2. And instead of square root 3 over 2, we're going to write sine 60. Well done.
Wow.
Right? And instead of cosine half, or instead of half, we write cosine 60 cosine x. Okay, that's that. It is a level, I would say it's a level 4 question. Because you have to like, I think so.
So I can't solve something.
Not easy. Okay. Now we're going to use the compound, and I think the compound formula, I can't remember what's the compound formula. The answer is sine, hang on, I've got a problem. No, it's fine. I think it's cosine. What is it? I don't have a formula. I think it's cos. Anyway, it's either minus. Yeah, it is minus 60 minus x. I think it doesn't actually matter. You'll see now. Okay. Now I'm looking for what's the maximum and the minimum. Okay. So what will be the maximum? What's the maximum? Okay, that's 2. What's the maximum that cos 60 minus x can be? Doesn't matter what's this. What is the maximum of cos can be? It's 1. So the maximum value can be equal to 2. Okay? The maximum of this is 1. So the maximum of this is 2. Yeah? 2 times 1 is 2.
Yeah.
Yeah? And the minimum will be?
-2.
Okay? Let's just check that we got it right. So, is this on? Yeah. This, when I first look at, again, we're trying to find out the minimum, the maximum. When I first saw it, I thought, okay, maybe we need to do 2 cosine squared. No. If we want to know what the maximum, okay, it's basically the maximum of this term plus the maximum of this term.
So 3.
5.
Yeah, you're right. What's the maximum that sine can be? 1, right? So the maximum is going to be 3. 3 times 1 plus 2 is 5.
Okay, wait, so like.
Okay, the minimum, we have to be a little bit more careful. What's the minimum that...
It's gonna be.
What's the minimum that can be?
It's gonna be
-1.
-1. No.
Well,
-3.
good.
What?
Can you explain why the answer is 2? What is the mistake that we've done here?
Oh, it's a negative.
Okay, let me explain because the bell's going to go in. If we had, let's do another question. If I had 3 sine x plus 2, then the minimum, you're right, Ollie, the minimum of this is going to be -3 plus 2, it will be -1. That's what you've done, right?
Oh, but it's squared.
It's a square. So what's the minimum that sine can be? It can't. What's the minimum it can be?
1.
It's 0. The minimum that can be is 0. It could be 1. That's the maximum, but it can be lower. Okay, let me explain that. Is this on tape? It is. Okay. So the minimum of sine square x is not -1. It can't be negative, but it can be 0. So it's 0 plus 2, and the answer is 2. Okay, we're gonna stop here, and I'll give you some homework, guys.